So today's classwork assignment is going to be thinking about rotations. So we learned a little bit about them yesterday, and we're going to continue today. All right, so the very first question asks us to graph the triangle on the grid. But what you'll see is there's no XY axes on this. All right. So what we need to be able to do is to actually create our own. Now, does it really matter where you put it? Not really. The points are low enough that I wouldn't have to worry about how high do I need to go or how low do I need to go. So I'm going to draw one somewhat right in the middle. I'll call that one my x-axis, and then I'm going to draw one down the middle and call that one my y-axis. Now again, I'm not counting the boxes. I'm just doing an approximation of where I think that it should go. And that one will be your y-axis. Okay, so now we'll go ahead and plot the points that they have given us on the grid. They have told us that point A is -3 and then up to 6. -3 and then up to 6. So remember, when you're graphing these points, to please make sure that you are labeling them with what letter they are. So this is point A. Then I'm going to go and graph 2, 4. So to the right 2, and then up 4. And C would be 3 and -3. All right. So I have my triangle here, so I'm going to connect them with a straight edge and make my triangle. Okay. So now I have our triangle, and they want us to be able to rotate this triangle down in number 2. Okay, so it says to graph the rotations, and again, it's very, very important that we understand that the rotation is about the origin. Okay, so when they say the origin, they're talking about the coordinates 0, 0. Right. Now, to be able to rotate this 90 degrees, now remember, if it does not state a degree of whether it's going to go clockwise or counterclockwise, we're going to always move counterclockwise. Okay, so I'm going to grab a sheet of patty paper that's been helping us for a while, and I'm going to make my XY axes. Now remember, the reason why I'm making the XY axes, there's my partial XY axes, is because the point is right here. And we create the XY axes because they form that 90-degree angle. Each corner is a 90-degree angle, so as we're rotating this, that's how we know if we're rotating at 90 degrees or not. Okay. Now what I'm going to do is I'm going to trace that triangle that's underneath, because that's the image that I am going to rotate, and it's the pre-image. So I'm going to trace that as well. And as I'm tracing it, I'm also going to label the A, B, and C so I know exactly where the A is going, where the B is going, and where the C is going. Okay. If I'm going to rotate this 90 degrees, I'm going to go counterclockwise. Okay. So I'm going to put my pen directly on the center of this and rotate this 90 degrees. So if you're watching this little plus sign here, as I turn it, that would make it a full 90 degrees. You might have to shift it a little bit to get your points to line up, because we need to make sure that we're on the exact plus sign. Right. Now looking at here, it looks like the A prime, remember this is going to be your A prime coordinate, is going to be 1, 2, 3, 4, 5, 6, and then down 1, 2, 3. So the A prime coordinate is now going to be -6, 3. So I'm going to move that out of the way. -6, 3. my B coordinate, 1, 2, 3, 4, and up 1, 2. So that's going to take -4, 2. And the C coordinate is going to be 1, 2, 3, 1, 2, 3. So now the C coordinate is going to be 3, 3. Okay. Now they didn't just ask me for the coordinates. If you look up here, they actually ask you to graph it after the rotation. So I'm actually going to graph those 3 points that I was able to come up with using the patty paper. -6, 3. Here's where the A prime was, or should have been. This coordinate should be -3. Okay. B is going to be -4, 2. So there's now going to be my B prime coordinate. And the C prime coordinate will be 3, 3. So then that becomes my image after a rotation of 90 degrees. And again, I'm going to connect them to make that triangle. So there's my image after a rotation of 90 degrees counterclockwise. Okay, now what I'm going to do is I'm going to complete the next piece where it says to rotate it 180 degrees. Now remember, whether you rotate it 180 degrees clockwise or counterclockwise, it's not going to make a difference, and I'll show you here. Okay, 180 degrees means 2 turns. So if I turn this once for 90 degrees, once for 90 degrees, there we go, twice for 180 degrees. Okay, so that's 180 degrees. You can see where it went when I went counterclockwise. Now if I put it back on and I go counterclockwise, there's once for 90, there's twice for 180. So you can see that it didn't matter which way that I went. Okay, I'm just going to shift this just a little bit to make sure it lines up at exactly this plus sign. And now we can see where A double prime, B double prime, and C double prime are going to go. Right. Now, this goes 3 down to 6. Right. So the new coordinates of A prime will be 3, -6. B prime will be -2, -4. And C double prime will be -3, +3. Okay. Right. So I'm going to graph those 3 coordinates onto my graph. Okay, 3, -6. There is A double prime. B double prime is -2, -4. And C is -3, but up to 3. And again, I'm going to create that triangle that it asked me for. So now we have 3 triangles on our paper, and we're able to distinguish the difference between all of them based on their letters. So the original has just an A on it. The first time that we rotated it has a single prime on it. And then the second time that we rotated it, we put double primes on it. That way we could distinguish the difference between all of them. Okay. So now if we're looking, we're going to actually complete what the main rule is for rotations. Okay. Now if we're going to rotate it 90 degrees, looking at a rotation of 90 degrees, Remember, that was the counterclockwise rotation. So the original A was -3, 6. And what you can see that happened is that the X and Y's actually switched places. So this is going to become Y and then X. As well as, well, that -3 stayed, but the 6 changed sign. Here it's the new X. So I'm going to negate that. Now, negate does not mean make negative. It means to change its sign. And that's what happened with all the coordinates. The original B was 2, 4. As you can see, the 2 stayed the same sign, but the 4 changed to its opposite sign, as well as the C, the original C. The first 3 became the new Y, and the -3 became a positive for the new X. So those you can't really tell that switched places, but they did. Now, if we're looking at a rotation of 180, here's the original, here's the rotation of 180. You can see they stayed in the same positions, but this went from being a -3 to a +3, and this went from being a +6 to a -6. So when we rotate at 180, we're not switching them, we're just changing their signs. The same thing happens here. A +2, 4 became a -2, -4. So therefore just the signs changed. Same thing for the idea of C. Okay. Alright, now we're going to come into maybe a new vocabulary word that you may not have heard of. This is orientation. When they're talking about the word orientation, they're talking about the order of the points. So I'm going to go back up to the original and show you what I mean. Okay. So let's take a look at the original. To get from A to B to C, I am going in a clockwise fashion to get from A to B to C. Now I'm going to test that. I'm going to test that with all the rest. So again, A to B to C was a clockwise fashion. Now if I look at the first rotation, prime, if I go from A to B to C, again, it moves in a clockwise fashion. So that stayed. That's the same order, clockwise fashion. Now if I look at the double primes, again, A to B to C goes again in that same clockwise pattern. So when they ask you is the order preserved in this, the answer is yes. And when it asks me to explain, the points stay in order going clockwise. So that's what they were looking for. Now we run into an old vocabulary word that we have been working with. Is this a rigid motion? And again, we use the patty paper, so it's clear that this should be yes. And the reason is because if I look at the original to the first rotation to the second rotation, they are all the same size and the same shape. So that's what they're looking for when they're asking you to explain if it's a rigid motion. Yes, because the images, meaning all three of them, are the same size, length, remember another word for length is distance, and angles. All the angles are the same as well. So if a rotation is a rigid motion, then that would make sense that all the triangles would then be congruent. So triangle ABC would be congruent to triangle A prime, B prime, C prime, which would also be congruent to triangle A double prime, B double prime, and C double prime, meaning all three of them are the same size, the shape, the angles, everything about them is the same. All right, now the next question has another vocabulary word in it as well. We've been working with this lately. We want to know if this triangle is isosceles. Okay, so in order to show it's isosceles, we have to prove that it has two equal sides. Okay, now remember, we can't just state which two sides are equal. We actually have to use mathematics to prove that they're equal. So I'm going to go back up to the top and look at the picture again. So remember, we're looking at the original one, which I will highlight in blue. Here's the original triangle. Now, by looking at this, we should be able to get an idea of which two sides we think are going to be congruent. Right? So it looks like side AB should be equal to side BC, but we need to prove that. So I'm going to prove or disprove AC is, sorry, that should be BC, BC, and the length of AB. I'm going to determine if they are the same or not the same. Now I'm going to use the idea of the right triangle by creating the right triangle with these sides. So if I go from B to C, B to C, I have gone right one and down 1, 2, 3, 4, 5, 6, 7. Okay. So that gives me an A value of 1 and a B value of 7 when I'm trying to create A squared plus B squared equals C squared. So I'm going to use the 1 and 7. So I'm going to do 1 squared plus 7 squared equals C squared. If I put that into my calculator, that's going to give me 50. Now remember, last step is always to take the square root. So I can leave it in that manner because I'm just checking to see if they're equal, so I don't need to really take the square root or to break it down. Now I'm going to look at AB and determine if it is or it is not the same. So I'm going to go from A to B. It's 1, 2, 3, 4, 5 boxes, and then down 2. Okay, so I'm going to get 5 squared plus 2 squared because I'm creating the right triangle to figure out the side C. So here I'm going to use 5 and 2. So I get 5 squared plus 2 squared equals C squared. Okay, if I do this in my calculator, 5 squared is 25 plus 2 squared is 4. That is 29. So that comes out to be, remember that's only C squared. My final step would be that the fact that that is square root of 29. Okay, so what we can see right here is that these aren't equal. So, but we still have a third side. So even though it looks apparent in my diagram that side AC is not going to be the same, I still need to show it. So I'm also going to find what AC is. Okay, so I'm going to go back up to this picture. And I'm going to do the same thing. I'm going to create the idea of this right triangle. Now I'm not making it too dark because I don't want to confuse the pictures of the rotations, but I can count that it's 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes down, and 1, 2, 3, 4, 5, 6 to the right. So that's a -9, 6. So even if I use a negative value, remember, negatives squared turn into positives. All right, so for this one, we're going to wind up with positive 81 plus 36. So 81 plus 36 is 127. And again, you have to remember that your last step is always to take the square root. So AC is the square root of 127. So now, it asks you to decide if triangle ABC is isosceles and to show your work. Well, I've shown the work, and I have found that nope, none of the sides are even equal. So therefore, this cannot be isosceles. So triangle, and I'm going to make a statement to say that triangle ABC is not isosceles because none of the sides are equal. Okay, now the extra credit is going to be slightly more challenging for students to find as far as the extra credit. Okay, I will give some assistance on this, but I'm not going to do it all. Hence the idea of why it is extra credit. Okay, now just as a reminder, the area of a triangle equals 1/2 the base times the height. Now, if we look at these triangles, they are not right triangles, so therefore we cannot use the idea of the Pythagorean theorem to help us out here. Nor are any of these sides straight. They're all slanted. So I'm going to have to be able to figure out the base and the height by doing mathematics. Now, I can use the idea of AC as my base. Now, if AC is my base, then I have to be able to draw a straight line from B to the base such that it would create perpendicular. Now, if it's going to be perpendicular, you have to remember the slope of A to C was down 9, right 6. So if the slope of AC was down 9, right 6, in order to get something that would be perpendicular to it, I would have to do the opposite, meaning positive, and then the reciprocal of 6, 9. Well, that means from point B, but I cannot go up 6 and then right 9. I don't have enough. So now I'm going to reverse that and go down 9 and back 6. Sorry, down 6 and back 9. 1, 2, 3, 4, 5, 6, and back 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So potentially I'm connecting B to this point here to get it to be perpendicular. So then you can see the height here. Now hopefully you should be able to calculate the slope of B to the point here. Okay, so at the extra credit point, I'm going to leave it as that. There is an easier method, so if you could just see me for extra help on the extra credit if you would like to attempt to do it.